In this example, we want to graph the function y equals the sine of negative 2x. So to help us with this, if you recall, sine is an odd function. So if anytime we have a negative value inside our argument, we know that this is just going to act like y equals the opposite of the sine of positive 2x. And we can actually just deal with this and graph this function because these two are going to behave the same way. So what is the amplitude? The amplitude of our function is equal to the absolute value of -1, which is just +1. However, this negative here, it's going to reflect our graph about the x-axis. And then the period is 2 pi divided by 2, or pi units. Our period is going to be pi units. So let's go ahead and start labeling all of our axes. So again, remember, in order to label your axes, you're going to take your period and you're going to cut it into quarters. And this is going to be where all of our key points occur. So here we have 1 pi over 4. This is going to be 2 pi over 4, which simplifies to be pi over 2. 3 pi over 4. 4 pi over 4, which is pi. 5 pi over 4. And then 6 pi over 4, which is 3 pi over 2. 7 pi over 4. 8 pi over 4, which is 2 pi. And we can label some in the negative direction. Negative pi over 4. Negative pi over 2. Negative 3 pi over 4. Negative pi. Negative pi. And then again, the amplitude is 1. So I'm going to make this 1 here and that -1 here. And it's just been reflected. So let's go ahead and graph this. So our sine function. If you recall the sine function, it's plotting the y values on the unit circle. So when our theta is 0, the y value is also 0 for our sine function. So at the x-axis and y-axis at the origin is where the sine function starts. So sine function starts at the origin. And then normally it goes up to a maximum value, but because it's being reflected, it's going to go down to a minimum. And then just like the cosine function, so remember our key points are x-intercepts, maximums, and minimums. So just like the cosine function, our graph is always going to alternate between maximum and minimum values while hitting an x-intercept in between. So it goes x-intercept, minimum, it's going to go back up to an x-intercept. And then at 3 pi over 4, we'll be at a maximum. And then at pi, which concludes our first cycle, we will be back at an x-intercept. So this is the first cycle of this graph. So there's one cycle. You can see it's reflected down. Normally it would open up and go to a maximum first. And then again, we can continue this same pattern. So we would hit a minimum next, and then we would go to a, a maximum. We'd go to an x-intercept, then a maximum, and then back to an x-intercept. So this would be a second cycle of this graph here. And then you could graph in the negative direction as well if you wanted to. I'm just going to graph these two cycles. So just like before when we talked about, the domain is always all real numbers for any sine and cosine function. These cycles are just going to repeat over and over and over again in both the positive and negative direction. And then our range is from our maximum to our minimum. So the range is going to be from -1 to 1, and the domain is all real numbers.